To generalize the equation of the sum of the distances of the 3 points, consider this figure here. Okay, so as you can see, this is an ellipse shape, and there are 4 points here: vertex 1, vertex 2, focus 1, and focus 2. Okay, so assuming that C is less than A. So what is C? So C is the unit distance between the focus to the origin. Okay. And then A is the unit distance from the origin to the vertices. Okay. So as you can see, A is greater than C. And then B is from here to the origin. Okay, B unit distance. Okay, so what we have derived is PF1 plus PF2 is equal to 2A. So PF1, that represents some point. Okay, some point of the ellipse. So for example, there's a point P here. Okay, so this represents the P, or the point, some point of the ellipse. Okay, so point, the distance of point to the focus 1, and from the point to the focus 2. So PF1 plus PF2 is equal to 2A. So why 2A? Because the unit distance from the origin or the center is A unit distance to the vertices, to each of the vertices. So if we add the unit distance from vertex 1 to the origin or the center plus unit distance from the origin to vertex 2, so A plus A, that becomes 2A. So PF1 plus PF2 equals 2A. Before deriving the general formula of an ellipse, let me have some summary. Okay, so in this figure, our center is the origin. So here, center of an ellipse is the origin, 0, 0. Okay, that is our center. And then the foci is for focus 1, that is 0, negative C. Okay, focus 1, 0, negative C. And then for focus 2, that is 0, positive C. Okay, so assuming C is the unit distance from the center to the focus to each foci. Okay, so each focus is C units away from the center. Then for any point on the ellipse, the sum of its distances from the foci is 2A. For the vertices, we have here V sub 1 and V sub 2. The vertices are points on the ellipse collinear with the center and the foci. Okay, as you can see in this figure, meaning to say collinear, meaning to say they lie on the same line. Focus, center, vertex. Okay, so if y is equal to 0, then x is equal to positive, negative a. Okay, and then each vertex is a units away from the center. Okay, that's like what we have illustrated here. From the center to the vertex, that is a unit distance, and also from the center to the vertex 1, that is also a unit distance. The segment V sub 1 and V sub 2 is called the major axis. Okay, so from here, Let me have some rosemary bulb. Okay, so from V sub 1 to V sub 2, that is what we call the major axis. Okay, so, and its length is 2a. Okay, and then it divides the ellipse into two congruent parts. For the letter B, we have this what we call convertex. Okay, so the segment through the center perpendicular to the major axis. Okay, so perpendicular, as you can see here, it is perpendicular to the major axis. Okay, it is called the minor axis. Okay, this is what we call the minor axis, and it meets the ellipse at the convertices. Okay, so here and here. And also, it divides the ellipse into two congruent parts. Okay, so part 1 and part 2. Okay, and if x is equal to 0, then y is equal to positive and negative b. Each convertex is b units away from the center. Okay, b units away from the center, and the minor axis W1 and W2 is 2b units long. Okay, b plus b equals 2b. Since a is greater than b, the major axis is longer than the minor axis. Okay. To derive the general formula, let us use the equation we got earlier. That is PF1 plus PF2 is equal to 2A. Okay, so we transpose this PF2 here to the other side. PF1 is equal to 2A minus PF2. So we will be using PXY. F sub 1 is equal to negative C0. And then F sub 2 is positive C0. Okay. So we will be using also the distance formula, which is so point P, that is x minus F sub 1 negative C, so minus negative C, that becomes positive C squared, plus y minus 0 squared, which is equal to 2A plus minus square root of x minus c squared plus y minus 0 squared. Okay, so to evaluate, we have x squared plus 2cx plus c squared plus y squared, which is equal to, we have 2a minus, that is x squared minus 2cx plus c squared plus y squared. Okay, so to get rid of the radical sign, let us multiply squared both sides. Okay, cancel. So we have x squared plus 2cx plus c squared plus y squared equals 2a squared is equal to 4a squared minus, okay, So 2a times square root of x squared minus 2cx plus c squared plus y squared times 2. That is 4a square root of, just copy, x squared minus 2cx plus y squared plus, okay, so lastly, just square this value here, get rid of the square root, so just copy. Okay, so we have x squared plus, minus 2cx plus c squared plus y squared. Okay, next is we will be looking for variables that has the same sign. Okay, so just like this, x squared and x squared, we can cancel this, and also c squared, and then y squared. Okay, so next is to combine like terms. Okay, so since 2cx has the same variable with this negative 2cx, we can combine this 2. So this becomes 2cx. We will transpose this negative 2cx here. So this becomes positive 2cx, which is equal to 4a squared minus 4a copy x squared minus 2cx plus c squared plus y squared. Okay, and then 2cx plus 2cx, that is 4cx, which is equal to 4a squared minus 4a x squared minus 2cx plus c squared plus y squared. Divide both sides by 4 since they have common factor, which is 4. So we have cx is equal to a squared minus a square root of x squared minus 2cx plus c squared plus y squared. Okay, next is we will be getting rid of this radical sign here. Okay, so to get rid of the sign, we have to square both sides, but to simplify, let us exchange these two. Let us transpose cx to the other side, and then this negative a square root of x squared minus 2cx plus c squared plus y squared to the other side. Okay, so we have a square root of negative becomes positive. Okay, x squared minus 2cx plus c squared plus y squared, which is equal to a squared. Positive becomes negative, so minus cx. Then let us get the squared equation. Okay, so a squared, that is a squared times x squared minus 2cx plus c squared plus y squared, which is equal to a raised to the power of 4 minus 2a squared cx plus c squared x squared. Okay, so let us look for common factor of this equation. Okay, but before that, let us first distribute a squared. Okay, so a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared, which is equal to a raised to the power of 4 minus 2a squared cx plus c squared x squared. And then we cancelled negative 2a squared cx since it has the same sign. Okay, and then the same variables, a squared cx, and then the same coefficient 2. So they are equal, so we can cancel this. And then let us look for common factor. Okay, so we will regroup the variables or the expressions. Okay, so we have a squared x squared minus, let us transpose this since they have the same common they have common factor, which is x squared. So minus c squared x squared plus a squared y squared, okay, which is equal to a raised to the power of 4. And then let us transpose this a squared c squared to the other side. Positive becomes negative, so a squared c squared. And then let us factor. Its factor is, let's factor out the x squared. So a squared minus c squared times x squared plus a squared y squared is equal to, let's factor out the common a squared. Okay, so a raised to the power of 4 divided by a squared, we have a squared minus c squared. Okay, so we have now the common factor a squared minus c squared to both sides. Okay, so let us use the we assume that b, to simplify, b squared is equal to a squared minus c squared. Okay, so let b squared is equal to a squared minus c squared. Okay, so we have now b squared x squared plus a squared y squared, which is equal to a squared b squared. Okay, so by letting b, this is because by letting b, which is equal to square root of a squared minus c squared, so therefore a is greater than b. Okay, so now we have this equation here, b squared x squared plus a squared y squared is equal to a squared b squared. So we divide both sides by a squared b squared. Okay, we have cancel 1, and then b squared x squared divided by a squared b squared, cancel b, we have x squared over a squared plus a squared y squared divided by a squared b squared, cancel a, we got y squared over b squared. Okay, so that's it. This is now our general formula or equation for an ellipse.